Hello students. So in this video, we will talk about applying measures of central tendency in research. Most commonly, when we talk of measures of central tendency, there are three major modes or methods that we use. The first is determining the mean or the arithmetic average of your observations. Now, the mean is the most reliable measure of central tendency because it takes into account all possible or all data in your data set in determining the middle, no, or the arithmetic average. However, the mean can only be used for numerical scales, all right, or any observations that takes into account numerical values or those with arithmetic values. The median, on the other hand, refers to the middle observation in an array, okay, or in a group of data set. The median is determined when your data set is arranged in increasing or decreasing order and then identifying the middle value. When we talk of the mode, this refers to the most frequently occurring value in a data set. Another measure, or it may not be a central measure of central tendency, but it's also considered as a measure where about the behavior of your data or the location of your data. Or this refers to the quantiles. No? The quantiles are the measures that tell you the location of your data in a data set. Okay, it can be classified into three methods by determining the quartiles, the deciles, and the percentiles. No? When we talk of the quartile, it refers to the cutting of your data set into 4 cut points, right? When we talk of the deciles, this refers to the cutting of your data set into 10 cut points, while the percentile is determined by using or cutting your data set into 100 cut points. So what is the formula for determining the mean for ungrouped data? So usually your mean is represented by an X bar, okay, which is determined or calculated using the formula of summation of X divided by N, where X is the summation of X refers to the sum of all the values of your data divided by the number of data that you have. So in this example, we have 7 observations of 12, 31, 12, 16, 12, 45, and 16. Now, to get the mean, you have to first add them all up, which will equal to 188, and divide it by 7. 7 because these are 7 data in your data set. If you divide 188 by 7, you get 26.857. The median for the ungrouped data, as we have talked earlier or discussed earlier, this refers to the middle value. It is usually represented by an X with a curved bar on an X curve, right? So to determine again your median, with this given data set, we have to arrange them in ascending or descending order. For me, I determined or I arranged my data in an ascending order. And when I arrange this in ascending order, I'll try to find the middle value, which is 16. So therefore, the median of this group of data is 16. As discussed earlier, the mode is the most frequently occurring data in a data set. It is usually represented by an X horn, or an X with a horn on its head. Okay? So your mode for this group of data set will be the most frequently occurring data. For me, I prefer it to be arranged again into an array to help me determine which one is the most frequently occurring. And as for this case, 12 is the most frequently occurring data in the set. Therefore, my mode is 12. You have to take note that sometimes there can be no mode in a given data set. If your data set has no mode, then the answer for that question is that the mode is undetermined. If there are two modes in your data set, then we can say that your data is, or your modes are bimodal. If it has three modes, it becomes trimodal. And if you have multiple modes, you can refer to that data set as multimodal. Now the quantiles measure the location, no, of your data and used to understand the location of the scores in your data set. Okay, so to give you a visualization of what is quantiles, no, or what is quartile, no, look at this number line, right? So imagine that this is your data set, and the quartiles are the count points where your first, or where your data exists. So for example, in this part, this refers to your first quartile, the second quartile, the third quartile, and the fourth quartile, or the maximum quartile. Same thing as with the decile, no? We refer to the first, the second, the third decile, decile 4, decile 5, decile 6, 7, 8, 9, and 10. Okay? While on the percentile is the first percentile to the 100th percentile, or the P99. Now, this talks about the location of your data in an array. So again, this is like looking into your median, but again, you're looking into some parts of that data in the median. Now, always remember that the median is the middle value. All right? So if you will look in the middle value, no, we can say that the second quartile is equal also to the median. The fifth decile, being at the middle, is equal also to your median. While your 50th percentile falls at the middle, is equal also to your median. So we can say that your median is equal to the second quartile, or quartile 2. Your quartile 2 is also equal to your decile 5, and your decile 5 is also equal to your 50th percentile, or P50. So it's used to understand the location of the scores in your data set. No? To determine the quantiles, or the quartiles for ungroup data, let's use this example. So this is the data set that we have earlier on. And we say that your 16 is always your median. To get the quartile, we use the formula Qn divided by 4. Q being the quartile that you're looking for, either first, second, third, or fourth. All right? And N refers to the number of observations that you have divided by the 4, because you divided the whole data set into 4 points, 4 cut points. So if we have an example, let's say, for example, we want to find the third quartile. We just replace Q with 3 because we are looking for the third one. Multiply it by the number of observations. This is 7, so that's why it's 7. Then divide by 4. Then we get 5.25. All right? So the 5.25, you estimate it, round up or round down. Okay? So in this case, we round it down, okay, to 5. Okay, the 5 signifies the fifth, no, data in your set. So if we determine the fifth data in your set, it's 1, 2, 3, 4, and 5. So the answer for the third quartile of this data set is 31. Okay, because it's the fifth data in your data set. Let's have another example. When we say deciles, when we try to compute for the decile, the formula is dn divided by 10, where d is the number of the decile that you're looking into, and the number of observations divided by 10. 10 being the cut points that you divided your whole data set into. So let's say, for example, you're looking for the second decile. Okay, so you replace d with the second decile value of 2, multiply it by 7, and divide it by 10. Doing this, you will arrive to 1.4, and you round up or round down based on the value, you get 1, or the first data in the set, which is your 12. Right? Now, if we have an example of percentile of en over 100, this we can multiply. We can get it by having an example. Let's say we're looking for the 85th percentile. We just replace the p with the percentile that we're looking. So this is p85, right? Multiply it by 7, and then divide it by 100. Right? So we get 5.95, or in this case, the sixth data in your data set. So we count again 1, 2, 3, 4, and 5, and 6, and it's 45. Right? Just make sure that when you get the decile or the quantiles, the quartiles or deciles and percentiles, always first arrange your array or your data set in an array like this one. You have to arrange it first, from either descending or ascending values. So for me, I prefer that we arrange our data in an increasing order. Right? So before we get or determine the quartile, the decile, and the percentile. The next topic that we will discuss is grouping our data. All right. So when we group our data, we are actually constructing a frequency distribution table. Now, constructing the frequency distribution table is determined using the 7 steps. First, we determine the range, which is equal to the highest value in your data set minus the lowest value in your data set. The next is to determine the class interval. All right. So the class interval is determined as 3.33, or by the formula 3.33 plus the logarithm of n, where n is the number of observations that you have. While the class size, on the other hand, refers to the for the class interval will tell you how many classes, how many categories will you have in your frequency distribution table based on the data that you have. All right. Now, the class size, on the other hand, is different. When we say class size, this refers to the number of data in a specific category or interval. Later on, I will show you the difference between the class interval and the class size. All right. Your class size is determined by the formula range divided by the class interval. Okay. While the class mark is another concept. When we say class mark, this refers to the to the middle point of your data. Okay, the middle point of your interval. So to get the class mark, you just have to do add the upper limit and the lower limit, and then divide it by 2. Okay, the class boundaries are determined using the formula of lower limit minus 0.5 and the upper limit plus 0.5. Okay, another important part of your frequency distribution table is your cumulative frequency. No, there's one concept, there's one column that we need to present in your cumulative frequency, okay, which is your increasing CF or increasing cumulative frequency, and the decreasing cumulative frequency. And lastly, your percentage distribution or your relative frequency. For example, we look into this group of data, all right? And we want to make a frequency distribution table. First, we determine the range. No? The range is determined by subtracting the highest value with the lowest value. In this case, the highest value is 23, and the lowest value is 9. So we subtract 23, subtract 9, we get 14. So the range is 14. The next step is to determine the class interval. So the class interval that we want is, we use 3.33 plus the logarithm of 20. So therefore, we're expecting around 4.63 or 5 class intervals. Okay, 5 class intervals. So if that's the case, then there should be 5. Now remember, when creating a class interval, it has to be an integer, okay, or a whole number, because this will determine how many classes, okay, how many classes in your frequency distribution table that you will have. The next is what you call your class size, no? Or the range, no, of values that will fall inside, no, a certain class interval. So the class size is determined by the range, all right, divided by your class interval. So the range is 14. We divide it by 5, we get 2.8. Again, we make this an integer so that it will be easier for us to handle our data. So it's around 2.8, or we get 3. All right. Now, the next step is to create the table itself. All right. So I already have a table here, but let me explain how I arrived with this one. So to create our class interval, since our class interval, the total number of intervals is 5, we have to make 5 categories. Okay, 5 class intervals. So this is 1, 2, 3, 4, and 5. Because our class interval for this one, all right, is the result is 5. Okay, the result is 5. So therefore, we should have 5 class intervals on this part. All right. On the other hand, no, the next step is to determine how many or what will be the range of this particular class interval. Okay. Based on our computation for number 3, we have 3. Okay, the class size should be 3. So therefore, when we create our class interval, we have to make sure that there are 3 values that will cover in that class interval. Okay, so we start first with the lowest value, which is 9. So that's why 9 is reflected on this part. Okay, so now we count 3 values because that's our class size, no, to determine the upper limit of our class interval. So the first one is 9. We count 3 from 9, 9, 10, 11, right? So therefore, the second or the upper limit of this class interval is 11. The next part is 12 because we cannot overlap these two. Okay? So the next value will be 12. Okay. The 12, from 12, we count again three steps or three values to determine the upper limit. So it's 12, 13, 14. So that's why we get 14. The next value becomes 15. All right. So we count again three values towards our upper limit. It becomes 15, 16, 17. So that's why this is 17. This one is 18 because we cannot overlap with 17 to 17 here. All right. So from 17 we get 18, and we count again three steps up towards our upper limit. So 18, 19, 20. So that's why we get 20 and 21. We count three values again: 21, 22, 23. All right. So this is our class interval. So we're done with the first column. The next column is to create your frequency. When we say frequency, the number of data that you will have or that occurs, no, in this group of data set. So let's in this step you're going to count how many, okay, how many data will fall into this category in your data set. Okay, so if we count 9 to 11 and look here, where are those? We can find 1, 2, 3, and 4. So that's why this is 4. All right. Same thing with this value. Okay, we find 12, 1, that's 1, 2, and 3. This is 3. So that's why this is 3. For the class interval of 15 to 17, we count again. We look for those values. We count and then we count. So this is 1, this is 2, this is 3, 4, 5, 6, 7, right, and 8. All right. So that's why this is 8. For the values that will fall in the class interval of 18 to 20, all right, we get 1, 2, and 3. So that's why this is 3. And for the class interval of 21 to 23, we have 2. Sorry for that one. We have 2. This is 21 and 23. So that's why this is 2. Okay, this is 2. All right. Now, if we add them all up, no, this becomes your summation of F. Okay. So this is the summation of your F, which gives us your 20. So that, all right. The next step is to determine the class mark or the middle point. No? Based on our formula, it's the upper limit plus the lower limit divided by 2. Okay. So for this particular data interval, we add this 2. 9 plus 11 divided by 2. So 9 plus 11, that's 20. You divide it by 2, becomes 10. 12 plus 14 is 26. Divided by 2, it becomes 13. 15 plus 17, all right, that's 32. Divided by 2, that becomes 16. So on and so forth until you arrive or complete this column. The next step, step 5, is to determine your class boundary. Your class boundary is determined by subtracting 0.5 to your lower limit, okay, and adding 0.5 to your upper limit in your class interval. So the class boundary for this class interval is 9 minus 0.5 is 8.5, while the upper limit, no, L11 plus 0.5 will be 11.5. Same, you will do it for the rest of the data or intervals that you have. Okay? So for this one, 12 divided by 12 minus 0.5, you get 11.5, and 14.5 for the other one, because you added 0.5, no, on the upper limit. So on and so forth. Now, the increasing cumulative frequency, or the increasing cumulative frequency, tells you the or the incrementing, no, the increasing cumulative frequency tells you the frequency when it's adding up, no, per per class interval. So you determine it by, first you get the 4, okay, you get it here, and then add this frequency to the next frequency of the second class interval, and then you will get 7. Now from this you add it here, so that you'll get 15. For the next part, the 15, you'll add 15 with the 3, and then you get 18. And you add 18 to 2 to get your 20. This one is the inverse, no, of your increasing cumulative frequency. This is the decreasing cumulative frequency, which is this is 20 divided by 4. 20. No, you start with 20 because you have 20. You subtract 4, you get 16. From here, 16 minus 3, you get 13. 13 minus 8, you get 5. And 5 minus 3, you get 2. So the relative frequency for this one is the percentage distribution of this one, okay, to the total. So you just get the percentage of 4 to 20. So that's 20%. You get the percentage of 3 out of 20, that's 15%. You get the percentage of 8 in 20, then you get 40%. Again, this one is 3 divided by 20, you get 15%. And 2 divided by 20, you get 10%. For a total of 100%. Okay? So this is the step, no, that you do when doing or constructing your frequency distribution table. Right. Now, your data now becomes group. Okay? Your data now becomes group. And you cannot use the formula for ungrouped data for group data. So to identify the mean, the median, and the mode, and the quantiles, we have a separate step for that one. So this is your formula for your mean, all right, for group data. So for the mean for your group data, we use your formula summation of f of x divided by the summation of f, all right, or the summation of frequency. So to get this one, we have to construct another column, which will determine the product of your frequency to your midpoint. Okay, so to get the mean of the group data, first we construct or determine the product of f of x, right? So we do this by multiplying our frequency by your midpoint. So 4 times 10, that's 40. 3 times 13, that's 39. 8 times 16 is 128. 3 times 19 is 57. 2 times 22, that's 44. Add them all up, you get 308. Okay, add this all up, you get 20. So notice that we used 308 and 20 over here. So 308 divided by 20, that's 15.4. So the answer for this group data mean, is 15.4. On the other hand, when we we determine the median for the group data, we use the formula x curve, no, divided by the lower limit of the median class plus the value of your median, no, the formula for your median minus the cumulative frequency, no, divided by the frequency of x or of the median class, no, multiplied by I. So this explains, no, the component of this formula, where the LLX means the lower limit of the median class, and divided by 2 refers to your median, or the number of observations divided by 2. Now, this one refers to the cumulative frequency preceding your median class, and also then f of x refers to the frequency of the median class. All right? While I is your class size. So to find the median in this group of data, or in this group data, we use this formula. Okay? So the first step is to identify the median. And to identify the median, we say that we divide, no, the number of observations by 2. So 20 divided by 2, that's around 10. That is 10. All right. Now, if we look for 10, all right, if we look, no, for the 10th value in this group data, okay, we look into our cumulative frequency. No? We look at our cumulative frequency. We will look here, where will our 10 will fall. No? Our median of 10 will fall. So let's see. The first is you count 1 to 4 because this value is 1 to 4. Then this count because this has three frequencies. So this has 5, 6, and 7. While your 8, 9, and 10 will fall in here. All right? So the 10th median, or the n divided by 2, falls in this class. Therefore, this is your median class. Now that we have identified your median class, we can now proceed with our computation. So replacing the values with the values that we get from the median class, okay, we do it by, first, the lower limit of the median class. So this is the lower limit of the median class. So that's why it's 14.5. Multiply by n over 2, which is 20 divided by 2, minus the cumulative frequency preceding, no, preceding the median, or the median class. So this is the median class. This is the cumulative frequency preceding the median class. So that's why we put here 7. And then multiply it by, we multiply it by 7. We divide it by 8 because this is the frequency of the median class. Okay, frequency of the median class, and multiply it by 3. Doing this computation, we will arrive to 15.63. To determine the mode of your to determine the mode of your the group data, we have to take note of this formula. Okay, we use this formula. Now, these symbols represent the following. No, so this one, DLL, the lower limit of the modal class. Okay, we have to identify the lower limit of the modal class, where F1 is the frequency of the modal class, while F0 refers to the frequency of the preceding modal class, while the F2 is the frequency succeeding the modal class, while I is the class size. So doing our computation, the first step is to identify the modal class. All right? So we identify it by looking into the frequency or or the the class or the class interval that has the highest frequency. So this one has the highest frequency of them all. All right. So now that we have identified the model class, so this one, we now identify or replace the values. So this is the model class. Right. Now, we have to replace the values. So based on our formula, this is the lower limit of the model class. So we place 14.5 in here. Now, we get the frequency of the model class, okay, which is 8. This is 1/8. And we get the frequency of the model class prior, no, or preceding the model class. So this is what the one that we're looking for. So we place it here. Okay. So the next part of the formula is looking into the 2, placing there the 2, multiplying it to the frequency of the model class, which is 8. Okay. Minus 3, because this is the frequency of the model of the interval preceding the model class. And the frequency succeeding the model class is 3 also. All right. So this is 3. If we compute it, 14.5, this becomes 1.5, we get 16. Now, getting the quantiles, no, in your group data is similar to your median data or median formula. Okay, we just have to replace, right? We just have to replace this one or this part. Okay, the lower limit of the median class, this one, and this one. All right. So replace the lower limit of the median class with the lower limit of your quantile of choice, and replace your n over 2 with the appropriate formula for the quantile that you want to find out, and also your cumulative frequency and your frequency of your quantile class. Let's, for example, we're looking for the third quartile of this data set. Okay, so we replace this one, the lower limit, with the third quartile that we're looking to. Okay, then we replace n over 2 with the formula of our third quartile, which is 3n divided by 4. And we take note of the cumulative frequency of the class interval preceding the third quartile class, and your frequency of your third quartile. And of course, your class size. So for this example, the first step that we do is determine, no, the value of your third quartile, which is 3n divided by 4. So this is 3 times 20, that's 60, divided by 4, because we divide it into 4 cut points. That gives us 15. So again, we have to, the next step is to identify the cut point, no, or the interval which contains our third quartile. So by doing so, we count again, 1 to 4, this is 4. 5 to 7, okay, this one falls here. And 8 to 15, your 8 to 15 falls here. So therefore, your third quartile class is this class interval, your 15 to 17. Now that you have known your third quartile class, we now substitute the values. Okay, so the lower limit of the third quartile is 14.5. So therefore, we place it 14.5 here. So we replace the n over 2 with the formula of our third quartile. which becomes 3 times 20 divided by 4 minus the cumulative frequency preceding the quartile class. So therefore, this is the one that we're looking for. This is your quartile class. This is the preceding cumulative frequency. So therefore, we place 7 here. We divide by 8. No? We divide by 8 because that's the cumulative, or that's the frequency of your third quartile, and you multiply it by 3. Doing the math, we arrive at 17.5. So the answer for this one is 17.5. So that covers our discussion of your measures of central tendency, right? I hope that you have understood my explanation, and if you have any questions, you can always send me a message. Thank you very much and have a nice day.